Alright, this time we're going to try making a different type of nixie tube. This one is going to have letters in it. It's going to spell out a company name. The fellow that's watching right now will get the idea, I think. I hope it works. The problem we have when we do something like this is we're going to have a long structure. And we have no way, if we have the seal at one end, we have no way to support these letters. We can't just string a wire up here and hang a letter on it. Because what would happen is they would bend together, or they might bend over and touch the envelope. It wouldn't be a solid structure at all. Now, one way of doing it would be with glass rods, arbors. But those have a tendency to break. You drop the tube or something, bump it, and it breaks those arbors. I mean, a long time ago in the old days of tube making, they used to use glass arbors, and they were notorious for getting broken. So that's not too good of an idea. But what happens if we use mica sheet? Now, the idea, we'll make the tube in 1-inch diameter Pyrex tubing, and we'll put a sheet of mica down the center, like so. Now that is inherently solid in the tube, and if we mount our letters onto that, then that will keep them from moving around in the tube. Now we have plenty of room on one side to put our letters and the anode, and on the back side we have plenty of room to run all the wires back to the seal. So inherently we're going to have a very solid structure that'll have no tendency to warp or change position. And we can position the anode very close to the letters and not have to worry about them moving in position, because they're going to be held solidly by that piece of mica. And the anode itself will be connected to the mica too, so the relationship will be kept very solid. Now, the pinch will be we have 8 letters, so we're going to put 8 wires through the 8 wires through the glass. Now, we'll take the anode and we'll bring it out on a separate wire, because if we put the anode wire in the same pinch with the rest of the cathodes, it's going to be so close where it comes through the glass that we're going to have a glow discharge that'll break over right at the glass, and no matter how much current we pump through it, that discharge will get brighter and brighter and hotter, and we won't get any light down on the rest of the electrodes. So we're going to take that anode and we're going to bring it out through a separate seal on the side so that we can get a good 1/4-inch separation between the pinch and the anode. And now for the anode structure, what we're going to do is we're going to make a frame that goes around the outside of the letters. It'll just be barely on the outside. It'll sit just over the letters. The separation will be approximately 1/16 of an inch. And we'll arrange it to where we have a wire going between each letter. Now, what that does is we have anode for this one, anode for that one. The O, we have anode very close all the way around the O. We have anode very close all the way around the C. We have anode close on the R. The inner part of the R might go ahead and place an anode wire. We'll just take and pinch one piece on like that to make sure the R lights up all the way. Okay, another O. Now on the T we do the same thing. We have that T that's a little bit further away from the anode, so we'll take another little piece of anode wire and just string it up there alongside the T. And then the E is okay. Now the center E we have trouble with because it's farther away from the anode, so we'll stick a little piece of anode wire over there to be close to the center part of the E. The rest of the E we have anode right next to, and then the C we're okay. Now that will be a nice anode structure that will not block out our letters. For some reason in some of these old nixie tubes, I mean, they used a screen in there that just really looked like hell. I mean, it blocked the heck out of the letters. I don't know why they did that. They don't need that much of a density of the anode. It can be a very open structure like this. Okay. Now, for mounting the letters onto the mica, what we'll do, I've made the N already. I don't know if this will focus okay. You see the little N there? Now, on the back of the N, I've extended little wires sticking out. Now those will go through the mica, and we'll put little glass spacers, and that'll hold it just a little bit away from the mica. We'll separate it with a little bead to where it'll be about a 1/16 of an inch from the mica. And that way we won't have the glowing electrode touching the mica. I don't know if it would matter, but we'll just go ahead and space it away a little bit just to make sure. Now, I've gone ahead and made a 1-to-1. I should have done it on the computer when I made this drawing, made a 1-to-1 for making the letters, but I forgot, and of course I erased the dadgum computer file, so I'd have to go scan it back in. I'm not going to bother. I'm just going to go ahead and use this handwritten 1-to-1 size one here and make up the letters. Okay, that's the N. I have an O that I made here. It has the little leads on the back to go ahead and support it. Now these are making out of iron. These are iron wires. It's just pure iron or steel, whatever you want to call it, wires. It's Fe. And I use that because it doesn't sputter. You know, steel is a low sputtering material. You don't want to use something like nickel, which, while it's a pretty wire, it sputters like all get out. Now to make a C, we bend it around a little form here. And then we'll just take it and bend it out a little bit. All right. Now, since we have trouble with the ends of the C not being near where we're going to put our through wires, we're just going to go ahead like we did on the O, and we'll just weld the wire right onto the tip of the letter and bend it over. No problem at all. Okay, focus isn't worth a damn on this camera. Now, we'll just grab that right at the weld and bend it back. Okay, and that gives us our support wire. Okay, and there we have a C. We'll straighten it out and make it just right when we go to mount it. Okay, now the R is a little bit more difficult to make because we have two pieces. We can't make it in a single loop. We probably could if we got real fancy. Okay, now on the bottom, we're going to start off with our support wire. Okay, then we're going to come up and we're going to bend over. Okay, then we bring it around. Okay, that looks pretty good. Now, what I'm going to do, I'm going to go ahead and Zorch that. Okay, that fastens that onto there firmly. Iron wire is a very easy wire to weld. It has a high melting point and high resistance, which is exactly what you want for welding. High melting point so it doesn't burn in half. You get something like stainless and it has such a low melting point that when you go to weld it, a lot of times it'll burn in half. Alright, now we're going to just take a piece and we're just going to hold it at the side here. Okay, maybe a little further in. And that's on there. Okay. And we'll cut that off. Okay, and that's our R. And then we'll grab it. Okay, now that gives us our support wire. Now on the top of the R, we're just going to put one support wire. We don't need to have two. We have two on the base, which will keep it from cocking side to side. And we'll just put one on the top, and that'll be okay. So I'm just going to go right like that. Zotch. Okay. And there's our little R. Okay. Now I'm going to just go on down and do the rest of these. You see to get the general picture here. There's no reason to blow the video time out just making letters. We've got all of our letters made here. So what we're going to do now, I've taken the piece of mica and I've marked a dot at each point where we have a support wire. And I'm going to take a scribe and I'm going to just punch the holes for the support wires. The mica just punches right through. I got it on a piece of soft wood and the mica punches right through. We don't have to use a drill. And I'm just making a little hole in the mica where each support wire goes. Very quick, very easy. And they need this way of supporting it because a lot of the pieces are very small, and trying to hang them all in the vacuum without any support would be a real nuisance. But if we can mount it all on a little piece of mica to support it, it'll make these projects a lot more practical. Okay, the next thing we have to do is we need some capillary tubing to make some beads out of. I wish I had some beads. I mean, you can purchase the beads, but I don't have any. What I did was I took some glass tubing and stretched it out and made some little bitty beads. You can buy these things at a bead shop, but I'm not going to drive halfway across town just for that. And I've drawn them down to where they just slide right over that wire. They're about 1/16 of an inch long, that 2.5 millimeters, something like that. And this is just going to hold the letter up from the surface a little bit so that the glow, man, well, that isn't going to work. Some of these have a little kink in them. I can't have any kink in that wire, otherwise the bead doesn't go down on it. See if I can straighten it. There we go. There we go. I have no idea whether the camera is getting this or not. All I'm doing is slipping the beads onto the end. Okay, there we have the 4 little beads on there. Now I'm going to stick the N onto the piece of mica, being careful not to lose the beads, hopefully. Okay, this is not particularly difficult. Okay, there's our N. You can see, I think, maybe, see it's spaced off by a little bit. Now hopefully that bead is going to stop those wires from glowing so that they won't interfere with the color of the N, or with the shape of the N. I don't know if they will or not, but we'll see. Okay, now what I'm going to do, these need to be, I'm just going to spread them out a little bit on the back so they won't pull out, or spread them in, whatever. I'm just going to bend them a little bit so they won't pull back in. Okay, got the end done. All right. That's going to be okay. Okay? Nocrotec. I think that's how you say it. I have no idea how you say it. And then this will fit right down inside there. Fits perfectly. Okay? The next thing we're going to do, I'm going to turn these wires off a little in the back here. Okay. That looks good. Next thing we're going to do is we're going to make the anode electrode that's going to go there. For the anode, we're going to use 12 mil stainless steel, hard drawn stainless steel wire. This is spring wire. This is not like the dead soft stuff. We're going to make the frame out of this stiff stuff so it'll stay put, and then we're going to use the dead soft just for the cross pieces. Alright, the first thing we'll do is we'll bend it. This is very stiff wire. Has no tendency to break when it bends. You know, it's not like the tungsten. Tungsten is very stiff, and if you bend it sharply, it'll tend to break. But this has got good ductility to it, so it doesn't tend to break. It's just plain stiff. We're just making the frame that's going to go around the outside of the cathodes. Okay, that's going to be our anode. Okay, we're putting our cross wires. We got some thin, stiff stainless, and we're just putting our cross wires for our anode. I'm just holding them in place, putting them right between the letters. Alright, there's our anode assembly. Okay, that fits right like so. And we're going to go ahead and we'll put it on there with some little glass standoffs just like we did the letters. Okay, now we've got our anode completely made, and we have wires fastened in 3 places here along each side, and that will keep it spaced evenly from the piece of mica. Alright, the next thing we'll do is we'll mark on the mica the exact place where our wires are going to go. By complete chance, you know, it's just absolutely hopeless. It is hopeless. My God, it's hopeless. Alright, that gets our mark. We're going to go ahead and punch the holes. Make the holes for these supports. This mica came from an old toaster, a bread toaster, Just took it out and took the heating elements away from it and cut it into the strip. I mean, you get some pretty good pieces out of it. This one's torn up here, but see, we'd have enough right there to make another one. And you can find other heating elements. This was out of some kind of an industrial heater, and each one of them has huge sheets of really nice mica in it. You just have to keep your eyes open on eBay, and you can find that kind of stuff for a few dollars. Okay, that gets our holes punched. Okay, now we've got spacers. And we'll slip one on each of the support wires. It's like trying to pick up fleas and okay, now I've got them all on there. Now let me see if I can get it stabbed onto the board. Okay, the big long one first. I thought that looked a little wrong. Hey, other than that, they look like they're fitting. No. It was trying to slip off of there and go on the floor. Caught it. Ooh, there it is. Okay. There's the anode. Alright, here we have, we'll see how it fits in there. I don't know if it focuses that good, but maybe it will. See, and that's solid. I mean, there's no way that's going to break. Okay, the next thing to do, that gets us our electrode assembly. That was one of the most questionable things that I had on this project. Okay, now I'll go ahead and do the glass work. Got to go ahead and make up the envelope and the pinch, and then we'll see what it takes to put it together. Alright, first we put a point, seal off the end of the tube. We got our pressure unit, lets us put pressure inside the tube. Alright, okay, next we're going to go ahead and blow a hole in the end and seal an evacuation stem onto it. Be a real pinpoint flame for that. A little bit of a big hole there, but we'll take care of that, no problem. What we'll do to take care of that hole, we're just going to flare the end of the tube a little bit. Use a carbon tool. Keep the joint up. Press the glass together. Alright, that looks real nice. That's our evacuation stem and envelope. Okay, next we're going to cut it off to the right length. This could be pretty long. I'd rather have it too long than too short, though. saw really goes through that neat. That is so fine. Okay, that gives us our envelope. Okay, the flare we're making with a piece of 4/10 inch tubing. We're going to bring that out to the diameter of our envelope in the back. Then we're going to make the pinch on the other side. So I'm just going to heat it up, use a carbon tool to spread the glass out. Alright, that's our flare. We'll go ahead and cut that off. Diamond saw is something else. Now the first thing we have to do is we're going to flatten it out so that we can get our wires in there. We got to get 8 wires in this thing. That's going to be quite a tight fit. Okay, to flatten it out, we take a piece of carbon. This is a flat blade of carbon that's about 1/16 of an inch thick. You know, maybe 1.5 millimeters or a little more. We'll hold it, the wire holder, and we slip that up inside the tubing. And we use a crossfire to go ahead and heat it. Just big mashers this time. There we go. Doesn't look all that hot, but it's good enough. You know, Pyrex is interesting compared to soft glass. In soft glass, if we did that same thing, it would be the most smooth, perfect look that you'd ever see. With Pyrex, to make it smooth and perfect, it takes quite a trick. I mean, you got to really play with it. But this is completely satisfactory. It'll work fine. Okay, next we have to prepare our electrodes, and we'll make the seal, hermetic seal. Okay, on this, we're going to use 9mm tungsten wire. Since we're going to put 8 seals through it, we're going to use a smaller tungsten wire. Now I've got, for the inside the tube, the electrodes are going to be 18 millimeter, not millimeter, but 18 mil nickel wire. And we're going to use 9mm tungsten for the seal itself. Okay, I've flattened the end of the wire so I can hold the tungsten on it easier. Grab it. And it's welded. Okay, we just grab it about the right place, bend it back and forth. Okay. And then we straighten her out. And there's our lead with the weld. Okay, we'll put another wire on the other end. Now I'm going to go ahead and do 8 of them. Alright, we've been pumping on a leak detector for about an hour. We've got it down to operating. And we're going to test now the seal. We've got the 8 feed through seal. Alright, let's see, get this down to 0. Oh shit. Oh no. Oh well. That ain't worth a crap. Okay, so that attempt was no good. Okay, we got a leak on that one, so we'll have to try again. That sure looked like a good seal. I'm not sure why it's leaking, but we're not going to build the tube with a leaky seal, that's for sure. Alright, what I did was I went ahead and reheated the seal and pinched it again. When I looked at it closely with a magnifying glass, I could see one wire that did have what looked like an air gap. And when I pinched it again, that completely got rid of it. So we'll go ahead and we'll test it. Adjust the helium here and get us a little bubbling. Okay. Now we're set on the most sensitive range of the mass spectrometer. And we're getting not the slightest movement of the needle. So we now have a perfect seal. Alright, we're ready to continue. Okay, next thing we're going to do, we're going to grind the hole in the flare for the anode. See, we're not going to put the anode in the same line as the cathodes, because we would have the anode so close to cathode that we'd get a flashover and we'd never be able to extinguish it. So what I'm going to do, I'm going to drill a hole in the flare, and we'll take the anode out through a bead seal through the side of the flare. To do that, we just take our Dremel tool and start grinding. We've got a ball mill in here. It's a diamond ball mill. And we just mill away at the glass. Doesn't take long at all. You don't run it at very high speed. You don't want to generate a lot of heat. I don't have a very steady hand. When you get old, everything gets shaky. It just means you got to try harder. There are other ways of cutting holes in glass, but this is one of the most effective, especially if you got steady hands. I'm too shaky. I tend to let it get out of control, but I've got friends of mine who are just so steady, it's just amazing. They just drill a hole right through. We just about got a hole in it. The glass is only about ½ millimeter thick, so it isn't a lot of drilling. Matter of fact, I think it's starting to come through. I might go through from this side. Got a hole all the way through. Okay, now I'm going to change to a pointed tool and we'll just open it up. Okay, this is a sharp pointed tool. It's diamond coated. The set like this from the Chinese is about $20. Excellent, very excellent material. It works great. Good quality. You just take the point. We just start working in a circle. We don't jam it down in there. All we do is work in a circle. And we'll open that hole up to where it's about 2 to 3 millimeters in diameter. I'm just going in a circular motion. Okay, and there's our hole. Took what, 2 minutes? Okay. Alright, now what we're going to do is we're going to fit the base onto the elements. Well, that has to go through. Okay, I'm going to cut off the anode support. Since the anode's going to connect from the front, we don't need them in the back. So I'm going to cut those off first and get them out of the way. connecting. Okay, see, we got the E we're going to put on the outside, and the C will go on the other outside. Oh, gotta be careful. Almost screwed up there. Okay, that looks extremely good. Okay. All right, I'm going to go ahead and weld those, and that will get our position taken care of. That good. Okay, and then for the C, okay, and I'm going to cut those wires off. Okay, now, okay, that looks good. And what we'll do is we'll make a beaded seal that'll go to this hole and fasten onto the anode, and that'll be well insulated from the rest of the cathodes. Okay, the next one, we have the E, which is already hooked up. So that means this one can be cut off. That's another one on the E. Okay, here's the T. We'll go ahead and make it the next one in line. I'm just going to grab it here. Bend it. Right? What I wonder if these are going to glow on the back. We have the mica insulator, and they're a lot further away from the anode, but there are little points of anode that stick through, so I don't know. It's going to be interesting to see whether they'll glow. Alright, that gets the T, E, and the C. Now, that O, I can just barely make onto this wire here. Okay. Okay, that takes care of that O. Okay, now we're done with that, so we can cut the other side off. Takes care of the wires that we can put directly. Now we'll have to start splicing and running them down. That one, so I'm going to cut all the others off. Cut that one, and these. Okay. Now the getter, we're going to hook onto the very end, and we'll put it up so it flashes up into the end of the tube. We want it out of the way. We don't want to flash it down here, because if we get getter metal on there short the contacts, then we'll have to blow them out with a capacitive discharge. And also the whole thing could start glowing if the getter gets hooked onto a cathode. Have the whole getter start glowing. That wouldn't be very good at all. Okay, all the letters are sitting about parallel to the anode. The whole thing fits up inside. We're going to put the getters right up here in the very top. Okay, the next thing, we need a beaded wire for the anode to bring that anode out through the bottom hole. So I'll make up another electrode and then bead it. Okay, I'm going to try to do this up close. I'll hold the camera because the tripod won't get in here. Now, what we have is our electrode wire. We've got the nickel part clamped in the wire holder. Got the little piece of tungsten, which is 9mm tungsten this time, and the piece of copper, which is the external wire. Now first I'm going to go ahead and flare it. This is to remove the oxygen. I'm taking a very hot flame, and I'm just moving it across it. Notice that we're not leaving it on the metal at all. We're just passing it across. The whole idea is to heat it to white hot and then move the flame out of the way so the oxygen in the air can react with the metal and form the oxide layer. Okay, that's enough. It's about 15 times or so. Now we have a small piece of glass here. This is a piece of glass capillary. Slip that onto the end here. Now the first thing we're going to do, I'm going to seal it onto this end. Too bad, overheated the nickel. Alright, we'll try again. Okay, got us a new piece of electrode. We'll flare it. That should do it. Alright, let's try again. This time I'm going to go with the copper first. Something that you don't want to do if you're going to set up a setup, do not mount your oxygen concentrators on the workbench. This is why I got so much vibration, is that the oxygen concentrators down below are vibrating like hell. And alright, now we've got the thing sealed to there. And what I'm doing is I'm just working along. Okay, that's a bead that we'll be using. Alright, here we have our seal that we just made, the little bead. Don't know if it'll focus on it or not. Okay, and that goes through the hole. And we're just going to take it right there and we're going to bend it. And we'll okay. Okay, that gets all our electrodes hooked up. Make sure we don't have any shorts. It all looks good. Now I'm not going to coat these cathodes in the back because I have two things. Number one, I think that mica is going to insulate it enough to where we're not going to get any glow back there. And I think that the mica itself will block that glow. If there is glow back there, it won't show up through the mica. Okay, we're ready to seal the tube up. Okay, we have to take two getters and put them on here and get them ready, and then we'll do the sealing. Okay, we're using a plain old half-inch ring getter. Now I'm just going to weld it to the anode and all. Okay. And there's our getter. Alright. And we'll be real careful not to flash it to where it's going to get up there and hide the letters any. Alright. Time to seal it together. Okay, the first thing we do is we're going to seal the outer rim, and then we'll do the bead. Now I've got the envelope clamped in one side, And I've got the flare clamped in the wire holder. Now we're a little bit misaligned, but this won't make any difference. We'll seal this first, and then we'll just bend the other end. We just use a small tip. This one, the camera makes it look a bigger flame, but it's actually about 1/8 of an inch in diameter. First, I'm just going to warm it up a little bit. Shouldn't have any trouble with cracking on this Pyrex, but you know, if you're careful, we're too close to a perfect tube here to take shortcuts. All right, we're flaring good. Now, this one point here, we're very close, so I'm going to go ahead and seal it there first. All right. Now I'm just going to work around. I'm just heating the glass up until it's plastic, pushing it into place with the carbon tool. A big gap here. See, we close it right up. Okay, now I'm going to put pressure using the hose and just even it out nice. Yeah, what's the plate? Some people say they can do this by hand without a lathe, and you know, all the powers to them if they're that good. But I tell you, this lathe is a real time saver. It's definitely worth the effort if you're going to do this kind of tube making to make a lathe. I mean, there's just it's just so convenient. Now I'm going to move the tube down to where we can get to that seal. And we're going to go ahead and seal the bead into the bottom. Okay, there's our bead. We're going to be working down inside there. It's going to be a very tight situation. Okay, I'm going to heat this back up. Now, this is a place where Pyrex is really good. We'd never get away with this with soft glass. We would not be able to reheat this and successfully keep it from cracking. There'd be a big juggle between an annealing oven and trying to keep it hot. But with the Pyrex, we just sit here and play with the torch just a little bit to reheat it. We have no danger of it cracking at all. Okay, we're up to flaring. Now I don't have the tool over here. Now to do the bead, what we do is we grab the wire and we heat the glass, and it's touching. I'm trying to get it on the other side. It is a very difficult thing to do. Okay, we got a hole in the back. I'm just going to take some glass and I'm going to fill the hole in. We don't want any leaks. Ooh. Go around that bead with the glass. It isn't going to hurt anything. Alright, the bead is in there. Now, I'm just going to take it and I'm going to keep it warm for a while. Let that bead come down in temperature. Alright. Okay, let's take it off of there and put it on the vacuum system and see if we got any leaks. Alright, we're on the vacuum system, and I've got our leak tester here, and I'll go ahead and open up the valve. Okay, see if we got any leaks. Big leak on there. Big leak on there. We're going to have to reheat that. The rest of it looks good. Okay, so we'll have to reheat that bead. We got a leak on that bead. Let me see where that leak is. I want to get that exact spot. It's in the back. That's where you'd expect it to be. Okay. See, now with soft glass, we would have no chance of reheating this without cracking it. But we can easily do it with the Pyrex. Okay, to reheat, we're just going to take the annealing torch and we're just going to play that on there for a while to go ahead and get it warmed up. Alright, that's enough. Alright, we're flaring. Okay. Boy, I can see it. I can see where it is down in there. Okay. Piece of glass. Alright, we'll just let her cool a little bit. that should do it. Compare that to the hour or two that you'd have to anneal it if you put it in if you had soft glass. All right, back into the. Okay, we're back in the vacuum system. Got our tester. Valve open. Pumping her down. Aha! Look at that. No blue glow at all. We're tight. Okay. Now, for this thing, we've got that piece of mica in there. Got a lot of gas in that mica. So what I'm going to do is I'm going to let this thing bake. Instead of 4 hours, I'm going to let it bake for 8 hours under high vacuum to make sure we get all the gas out of that mica. Now, I don't think it would be serious, but it may be. It may be enough in the mica to make it to where it would make the tube go out eventually. But by baking it for 8 hours, we ought to be okay. Okay, we'll come back in 8 hours and see what it does. Okay, we've got the thing, we've got it on the voltage now. It's been pumping for 10 hours, and I haven't flashed the getter yet. I've got power on it just to see if it's going to work. This is our charging manifold here. We've got helium, argon, and neon, and this is the gauge tube. We're reading the gauge back in the back there. That's the one that was in the video calibrating a vacuum gauge. We have our tanks of gas. We have a helium, our neon, and our argon. I think my argon is about empty. I'm going to have to fill it again. I've got cartridges of argon and I need to just fill it. But I'm not finding that argon is that useful. It makes a beautiful blue glow, which I'm going to show you in just a minute. Right now, we've got 15 torr of neon, and it gives an excellent glow. We're running very low current. I mean, we can run that current up and it gets really bright. But it looks like that's about the right pressure right there. We can move this around. There's a T, and that one is a C. There's the E. That looks like it gives us our best glowing on the elements. So what I'm going to do is go ahead and I'm going to seal this off. I want to get this tube done. And what I'm going to do is I'll make another tube up and I'll show you the effects of different gas mixtures, because it's not the way I thought it was going to be. We're not getting the variations that I was getting when I was using it in lasers. Okay, so what I'm going to do is flash the getter, and then we'll go ahead and we'll put 15 torr of neon in it. And that'll finish this tube off. We'll seal it off, and that'll get this one finished, because I want to get this one finished and out of here. Okay, I'm going to shut this off. Okay, we're going to flash the getter, then we'll go ahead, put the 15 torr of neon in it, and then we'll go ahead and seal it off. Okay, the first thing we have to do is take the pressure back down to 0. I'll open the main valve. Pressure goes down to nothing, because when we flash the getter we have to have very low pressure in the tube, otherwise the getter won't flash correctly. If we're above about 1 micron, then the getter is not going to flash correctly. We have to have it below 1 micron to flash it properly. Okay, now, first I'm just going to hit it a few times to go ahead and get the blast of air out of it. Let it just pump down a little. I'm just watching the main vacuum gauge and wait until it gets down into the 10 to the minus 5th torr range again. Okay, that's about 2 times 10 to the minus 5th torr. Okay, we're going to flash it. Alright, there's our getter. Alright, now we're going to open the helium and put us 15 torr. Let's see, I got to close this valve or we'll blow it all into the vacuum system. There we go, 8, 9, 12. Okay, let's try that and see what it looks like. Guess it would help if I plug in the power supply. Oh yeah. Okay. That looks good. Okay, we're going to just leave 13 nils on there. 13 torrs of... Oh, that looks really good. That looks really good. I don't like that. That N. Look at how that N is. That's not good there. Okay, let's try again. We'll go for a little bit lower pressure. Well, let's try a little higher first and see. Maybe the other way. A little more neon in here. No, as we go up, we're getting worse. Okay, so we're going to re-evacuate it. Okay, let's take it up slowly and we'll watch the glow. 6, 8, 10. There it is. Okay, it looks like about 10 to 11 is going to be our best, okay? For some reason that N, which I'm not really sure why, I'm going to have to play with this more to find out why they don't light up evenly. Maybe the getter flashed up in there and did something to it. Okay, that looks good though. We're going to go ahead and leave it at 11 torr. Okay, here we go. What I'm going to do is I'm just going to warm it up until it starts to collapse and then twist it off. It's starting to collapse. There it is. Okay. There's our Nocrotec tube. We'll see if it works. Okay. We'll let that tip cool off a little bit, and then we'll hook electricity onto it and see if we can get it all to light up. Alright, we got the voltage hooked onto it, and there it is. I don't know how you say the word, Nocrotec? Okay. The N is a little bit uneven. I'm not sure exactly why. The rest of them look pretty darn even though. I just picked resistors to get them all glowing about the same. I don't know that they have to be different. But there it is. I think somebody. But clearly the mica sheet works very well at holding the things in place. And we're running the power supply. We're sitting right at 250 volts. And for the whole thing lit, we're at I don't know what that is. Oh my goodness, we got something there. I'm going to cut the voltage a little and see if that goes out. I don't know what that is. Got kind of a glow down underneath there. I wonder if we've got some outgassing from heat, because it is getting warm. This thing may not work. Well, we're going to find out, because look down here. See, we got some kind of a blue glow down underneath there. I wonder if the mica is outgassing. Well, we're going to find out. Well, that's it. Okay, here's where part of our problem is. We have some breakdown in the back here and some breakdown here. So clearly we're not going to be able to leave the wires uncoated. Those will have to be coated from now on. Okay, this is an experiment. I mean, the whole thing is an experiment to determine all of this stuff, what we'll have to do. So these will have to have glass rods on them, and then coat them with insulation. Well, we'll just see what happens. It's been pumped for 10 hours, so there shouldn't be a lot of gas left in it.